Hey guys, this is your friend Maina from Civil Center and welcome also back to our channel, another video on estimation. So friends, in today's video and in this new year we will start with the bar bending schedule of beams. So now in the bar bending schedule of beams we have a beam and we have the reinforcement. In yesterday's video you had seen how we had inserted the reinforcement in Revit Structures. If you haven't watched that, you can watch that now, and we are going to find out the BBS of a particular beam here. Let's take this beam B2 of mark B2 and we'll find out the particular BBS of it. So let's quickly just calculate the lengths of it. So this particular length, if we check out the IS code, the shape will be like this for the bottom bars, and mirror of this from the opposite side, for the top bars. So let's just write the size in the format. So the size will be 4.105, that is this length, plus 0.25 by 2, 0.25 by 2, that is 0.25, since the beam width is 0.25. So this we have done here, and the particular shape of this, so this is a discontinuous end, so the shape will go like this, it will bend like this here, as you can see. So this is the shape of the bar, but one side is discontinuous, and the side C, that is the top end in this diagram, in this here, the beam will bend like this, and in this end, along this end, it will go continuous. So it's in this continuous end, so we'll have 0 here, and if this is B, so B length is 4.355. we've calculated this already, and the C, that is the bend length, that is this one, we are taking as 0.4. if it's mentioned in the structural drawing, you can take as per that. So this is the lengths which we have calculated, and now let's fill up the remaining things. The main reinforcement at the top, let's check out diameter of bar for the main reinforcement at the top. So diameter of the bar for the main reinforcement at the top is will have a 16 mm bars, 2 bars of 16 mm at the top. So we have 16 mm bars, number of bars are 2, and number of members, we have B1 of size, if you can check, sorry, B2 of this size, we have this B2, and this one is also B2. So these two B2 we can, this one is also B2, but this one is your continuous, and this one is continuous. So both of them we can take because both of them have the same size and similar end properties. So let's take 2. We are calculating the BBS of these two. So B2, and the number of members will take as 2, and the cutting length of bars will be the sum of these 3, which will be the cutting length of bars. And since it's less than 12 meters, we don't need to consider laps here. So now the total length of bar will be the multiplication of number of bars into the cutting length of bars into the number of members also. So this will be the total length of bar, and the total length of bars in all members. Okay, if you just if you need this table, you can do this, or we can delete this particular table as well, as per your preference. So total length of bar in all members, I will just delete this. So now we are good. This is the total length of bar. We'll do this length of bar, length of one bar, length of one bar. Now this is less confusing. Length of one bar and total length of bar in all members. So this is multiplication of this length of one bar into number of members. So the weight per kg is d square in by 162. We all know that d is in mm, and the total weight will be d square by 162, that is weight per kg per meter into the total length of bar. So we'll have the number of the total weight of the reinforcement at the top. Now about the reinforcement at the bottom. So the continuous reinforcement at the bottom we'll look at. So the continuous reinforcement at the bottom is your 2 bars of 12 mm. So 2 bars of 12 mm is what we have at the bottom, and the shape of the bar will be the same. We will just simply take this into account and drag this. The shape of the bar is the same, and number of members will also be the same, because and the cutting length of bars will be the addition of this. Length of one bars will be your same total weight, and the remaining things will be same. So we have done for the main reinforcement. Now let's find out the extra reinforcement. So the extra reinforcement is the start, end, and center. So start and end is at the top. So at the top we have extra reinforcement of 2 bars of 12 mm, and at the bottom we have extra reinforcement of 1 bar of 12 mm. So the extra start we have 2 bars of 12 mm, and extra bottom we have 1 bar of, sorry, number of members will have equals to this, and here also will have equals to this one. Here also we have equals to this. So the number of members will be our same for all. And now the cutting length. So the extra reinforcement you can or you cannot bend it as per your choice. So you'll only bend the main reinforcement. So this will keep as 0 0, and this one, this length will be the same as this for the cut reinforcement. And now we have the option of dividing this particular length. So since this will be cut reinforcement, so let us check out the length before deciding it. So it will decide it after seeing the drawing. So as you can see, the cut reinforcement at the top, now you can see the section here of any beam. So the cut reinforcement at the top is 0.1 L from here, and 0.3 L from here. So this is the cut reinforcement which you can provide. So basically need to know the L, and you can calculate since the 0.1 L, 0.3 L. So L is basically the center to center distance. So L here is 4.105. So you can do it equals to start at the end, and the top you can point 0.1 into 4. You can check out the value here, 4.105 from here. Simply take the value from here. So 4.105, 105. So this is the particular 0.1 L. And if you want to take a little bit extra, if you want to take out the extra beam, so suppose up to this portion, so this is 0.1 L from here, but we'll take it up to this portion. And if you want to give a bend also, you can include that also. Suppose we'll include that in C, that is in one end we'll just give a particular bend for it. At the start we can simply give an additional length here. So let's keep it 0.405 plus this particular length of the column. Let's take a little bit extra. So we'll go with point. Let's check out the column which we have here, and then we can decide. So this is C3. This is C3. So let's go with the common value of 0.25. So this much we can go for this, or you can even go with 0.3, little bit on the higher side you can go. So this is basically we are taking considering the particular extra reinforcement up to here, up to this portion we are considering, and for the main reinforcement we are bending it like this. So we have done with this. Suppose this is the start, and this particular beam will this particular beam will go up to this much, and at the end, or at the end top, the value will be like 0. You can take it from here, and we can paste it here, and this value will be 0.3 into 0.405, but in one end only we need to add this. So if we are considering this as the start and this as the end, so at the end we don't need to consider the particular particular extra reinforcement. Or when we'll consider this particular bar, we'll take the BBS of this particular bar, will not provide, take this extra part. So this is the end. At the end we'll also simply do this 0.3 into that particular length plus zero point 0.3, we'll add that, and this will usually be 0 and 0 since there is one shape only. And so this is the remaining things we have already given. The cutting length of bar, the total weight of bar will automatically be calculated. Now let's go for the center bottom. The center bottom, we have one bar of 12 mm, and the cut length will be simply, as you can check from here, so this is 0.25 L from this particular end, and 0.25 L from this particular end. And leaving that, the whatever the value is, you can provide the particular beam at this particular space. So if we go here, 1 minus 0.25 minus 0.15, so it is, the value is 0.6. So for the 0.6 L, you can simply provide the particular extra reinforcement at the bottom equals to 0.6 into the particular value which we have right here, that is 4.105. so 4.105 which we have here, and you've calculated, this is basically 0 and 0. And now we have calculated the particular extra reinforcement at the bottom as well. Now for the stirrups, so let's see the stirrups which we have here. So stirrups which we have is at the support we have 80 at the rate 125 center to center, and at the end we have 80 at the rate 150 center to center. So the stirrups will be provided in this zone. So let's take the diameter of the bar as like 8 mm, and number of bars we can simply take as this particular value which we have, and this also will take this particular value, and we can simply calculate the number of bars from the total length here. So if the particular length, if the total length is here given 4.105, so if we divide 4.105, because the bars will usually be avoided at the beam column intersection, so let's minus 0.25. so minus 0.25 we had deducted because we want the length from this end to this end, that is from the column to column. So let's we have taken this particular value. Now we can use that for considering the particular length. So let's consider the one third of the length near the support, and or one fourth of the length near the support, and one fourth of the length near the other support, and the particular remaining portion at the center. So at the support we'll consider two fourth of the length, so we'll multiply this particular value into 2 by 4. So 1 by 4 and 1 by 4 near the two supports, that is 2 by 4, and this particular value should be divided by your 0.1125. Now we can use the round up command here to get a round value, round up, and comma 0. Let's see if it works. So we can simply check up the arguments here, and then we can finalize here. So this is a particular value, this into 2 by 4, and this we can have a bracket here, and we can close with one here. We can simplify this. Let's simplify this like this and then press enter. So like this you can have the number of bars for the particular stirrups, and number of members you can check equals to this one, and this one is also equal to this one. So at the center you can simply copy this particular commands, and you can use them here, and in place of this 2 by 4, this will be actually the same as 2 by 4, because at the center this much space will be left. So the number of bars we are getting here, number of members we have already here, and the shape of the bar will have the shape of the bar and the stirrups which we had calculated in a similar way for the columns. So the shape of the bar will be somewhere like this. We can check out here in this particular view IS code. So the shape of the bar will be like this. So it will be 2 into A plus E plus 24D. So we are going to check out our particular length of the stirrups. So this is 250 into 350. So this particular cutting length will be your, so since the length is 0.25 into 0.3, if you can check out here, the B2 is 0.25 into 0.35. So one length will be 0.25 minus the cover, that is which you are providing. So we'll give the length 0.25 minus the cover. If you can check the cover of the beams which has been given in the structural drawing. So the cover for the beams is 25 mm, which has been given here, and 0.25 minus 0.025 into 2, that is 0.50. We'll just write 0.50 here, and this is one length which we have, and this length into your 2a plus e. So this length into 2, or you can simply multiply 2 here, 2 into this length. So this is the one particular length, and plus, can add plus here, plus another length is 0.35, 0.35 minus 0.050. So 2 into a plus e plus 24 plus 24 into d. 24 into d will be your, we have particular 8 mm bars here, 0.008. So like this you will have the cutting length of the bars. So this will be, as you can see, this will be the same for this, the cutting length of the both the stirrups will be the same, and the length of one bar will be this cutting length into multiply the number of bars, and the total length of bar will also be the same. Weight is also d square by 162, which we have here, and the total weight is also calculated in a similar manner. So like that we can calculate the weight of both the stirrups and the main reinforcement in the beam. So hope you found this video useful, and for more such videos we'll keep bringing more such videos on different topics. You can stay tuned to our channel, and if you want professional training from us, then you can contact using the number which has been given below. Bye for now. Have a nice day.